Talk about chemical engineering. What even is a chemical engineer? I bet for a lot of you, the answer is wrapped up in some old stereotypes. So today, we're going to bust those myths and get to the reality of what they really do. And trust me, it's pretty surprising.
So, be honest. When I say chemical engineer, what's the first thing that jumps into your mind? Is the picture a little fuzzy? Maybe it looks a bit like a cartoon character? Well, hey, if that's you, you're definitely not alone.
Yeah, I'm talking about this guy, right? The classic chemist with a hard hat, surrounded by bubbling beakers on one side and giant, complex pipes on the other. It's the go-to image, the classic stereotype. And look, it's not completely wrong, but it misses the absolute best part of the story.
All right, so to really get it, we've got to draw a super clear line in the sand. We need to separate two jobs that sound similar but are worlds apart: the chemist and the chemical engineer.
Okay, check this out. It really breaks it down. See? A chemist. Their whole world is discovery. They're at the lab bench, working with tiny amounts, maybe just a few grams, trying to answer the question, hey, what is this new thing I just made? But once they found that amazing new substance, a completely different and frankly huge question pops up. Okay, great. Now how do we make tons of this stuff? And how do we do it without breaking the bank or, blowing something up? And that's when the chemical engineer steps in. Their entire focus is on design and production, on a massive industrial scale.
So the big idea to grab onto here is that chemical engineering is really process engineering. It's not just about the chemical reaction in a beaker. It's about designing the entire system. We're talking the giant reactors, the pumps, the control systems, the whole shebang that can take raw materials and turn them into valuable products again and again on an enormous scale.
And that right there, that leads us to probably the single most important concept in all of chemical engineering: scaling up. This is all about that epic journey from a tiny little discovery in a lab to a product that literally millions of people can use.
Seriously, think about almost anything you've used today. Your phone, your soap, the clothes you're wearing. It all started with some lab research, right? That's the chemist's playground. But what happens next? The process design, building the actual plant, and then the mass production? That, my friends, is 100% the world of the chemical engineer. They're the ones drawing up the blueprint, managing the construction, and making sure the whole operation runs smoothly.
Okay, let's make this super concrete. Picture this: a chemist in a lab has a eureka moment. She's just created a revolutionary new biofuel, right here, in this single beaker. We're talking 500 milliliters. A brilliant discovery, for sure, but it's just a tiny amount.
But to actually power cars, you don't need a beaker's worth. You need something more like 50,000 liters every single day. And that massive jump, that incredible leap in scale, is the core challenge a chemical engineer lives to solve. How on earth do you take a delicate reaction that worked perfectly in a small glass beaker and make it happen inside a giant steel reactor? Safely, efficiently, 24/7? That's their superpower. Okay, so we've got the what down. Now let's talk about the where. And I'm willing to bet it's not what you're thinking. A lot of people just think oil and gas, right? The picture. Today, chemical engineers are right on the front lines, tackling some of the biggest challenges our planet is facing.
I mean, just look at this list. Absolutely staggering. These are the people creating the processes that let us mass-produce life-saving medicines